Hello and welcome to my Stats Finder project. So my question was, does changing Rubik's Cubes cause the difference in solving speed? And so recently during quarantine I've been pretty bored, so I ordered a new Rubik's Cube. I've been cubing since like 8th grade, but I've never been really serious about it. The difference between my new cube and my old cube is that my new cube, it's a lot looser, which means I can turn it a lot faster, basically. So to collect my data, I had an experiment. I solved each cube 50 times at similar times throughout the day, which means I solved it at around the same time at the same place, which is my desk. And I solved each cube 25 times. I took a break and I solved it again 25 consecutive times. This is so my fingers wouldn't get too tired and potentially slow down my solves. So let's talk about the filter and the curve. So the factor is a type of cube. There are two types of cubes I use, my old cube and my new cube. There's one level, and there are two treatments, because 2 cubes times 1 level is 2 treatments. The response was the time of the solve. As for the curve, my control was the old cube, because I wanted to compare my new cube to my old cube. I randomized through a randomizing algorithm. More on this later. This is replicatable. Yes, this was, because you can solve each cube very easily in parameters I stated before. I did not need to block, and it was not possible to blind because it's very obvious to tell if I'm using the old cube or the new cube. So I'll now show you a video on how I solved the cube. Hello, so I'll show you guys how I scrambled up my cube. I use this website called rubix.com, which is very helpful because it actually automatically generates a scrambled cube for you. And all you have to do is follow these letters on top, and they tell you how to scramble up your cube. So up, clockwise, front clockwise, left, up, down, counterclockwise, front twice, down, left, right, twice, right, front, down, up, right, down, up, front, and down. And you can see that there's actually a picture here that shows you what the scrambled cube is supposed to look like. You can see that my cube matches that cube. Yes. And I'll solve my cube now. To start, I'm going to press the space button or the space bar, and when I'm done, I'm going to press it again to record my time. So solved. Welcome back. So this is my data. Pretty boring, but you can pause it if you like boring stuff to see the data, I guess. And here are my histograms. So you can see that they're both skewed right, although my new cube is skewed more so, I would say. And you can see that the mean for my old cube is around 43 seconds, and the mean for my new cube is around 36 seconds. So let's talk about you can also see that they're kind of normal, mostly normal. So now it's time for the assumptions and conditions. So this is quantitative data, obviously. It's mostly normal, as stated before. Each solve was independent and each group was independent, which means that the solves between each cube were also independent. These were also randomized solves. So I decided to do a 2-sample t-test. My null hypothesis is that there is no difference in the times of the new cube and the old cube, and my alternative hypothesis is that there is a difference in the times of the new cube and the old cube. So now for some useful stuff, you can see the actual means over there on the left side, and my t-value was around 6.3, and my p-value was very low. So my conclusions is, since the p-value is low, we reject the null hypothesis, and there is strong evidence that changing cubes does not result in no change in time. So basically, changing cubes does make a difference, but I want to know by how much. So since the assumptions and conditions were already stated before, I'm going to do a 2 sample t interval. So I'm going to decide to do a 95% confidence interval and just plug it into the equation, and then you get it out. Now my confidence interval is around 4.5 to 9.2. So my conclusion for this 2 sample t interval is that there's a 95% chance that the actual increase in time caused by the change in my Rubik's Cube is between 4.5 and 9.2. So this is pretty good because my time before was at around 43 seconds, which means I improved by assuming that the actual value is in my confidence interval, of course. That means that my time increased by around like 10 to like 20%, which is pretty good. And thanks for watching my video.